Hello everyone, welcome to my YouTube channel. I am G. Kiran Kumar from Amrita Vishwa Vidyapeetham, Amravati campus. Today I am going to explain you from scratch about radio buttons and radio groups in Android applications. So, what are we learning today? To start, it's important to know that radio buttons and radio groups are fundamental components for developing user interfaces in Android. They are crucial for creating intuitive and efficient user interactions. Let's break down the two core components. First is the radio button, which is a two-state button that allows a user to select exactly one option from a set. Second is a radio group, which acts as a container to logically group these radio buttons, ensuring that a user's selection is exclusive within that group. Our learning objectives for this video are to first understand the core concept and structure, second, learn the proper XML implementation, third, see the practical Kotlin implementation, and finally, review essential best practices for user experience. Let's make a closer look at the radio button itself. First, its definition. A radio button is a specific type of two-state button used to represent a single choice within a limited set of options. Next, exclusivity. This is its key feature. Unlike a checkbox, which allows for multiple selections, radio buttons enforce a single choice decision. When grouped together, only one radio button can be in the checked state at any given time. This brings us to state management. A radio button can be in one of two states, as you see in the image, checked on, unchecked off. By default, all buttons starts as unchecked. A perfect real-world analogy for this is selecting one correct answer from multiple choices in an MCQ test. You can only pick one. Now, let's talk about the radio group, which is the exclusive container for our buttons. Let's look at its purpose and function. First is its container role. The radio group acts as a parent layout specifically designed to contain and manage multiple radio buttons. Second, its most important job is enforcing exclusivity. The radio group automatically handles all the logic for you. When you select one radio button, it automatically unchecks any previously selected button within that same group. Third, it provides layout control. A key attribute here is Android orientation. This lets you arrange the radio buttons either vertically, which is in default, or horizontally, giving you flexible UI design. To build this in our app, we need to understand some essential XML properties. These attributes are key to defining the appearance and behavior of your radio buttons and groups in the layout files. First is Android ID. This is unique identifier like ID at the rate plus ID slash my radio group, which is required so we can access this view from our Kotlin code. Next is Android text. This is visible label that's displayed next to the button. For example, accept terms. Then we have Android checked. This is Boolean, either true or false, that you use to set the initial selected state of a button when the screen first loads. A best practice is that only one button per group should be set to true. Finally, there is Android orientation. This attribute is for the radio group only and it determines if the button inside are arranged vertically or horizontally. Here is the core XML structure for our application. First, we have our radio group, which we have given the ID travel mode group. Inside it, we have defined our radio button options. You can see the options for our bus and train here. Notice the line Android checked equal to true on the train button. This is important as it sets train as the default selection when the app first starts. The other buttons for car and bike are also in this group. Below the group, we have defined a button with the ID submit button and a text view with the ID result text. The button will capture the user's final choice and the text view will display it back to them. Now, let's look at the Kotlin code that brings this layout to life. This slide shows the Kotlin code that controls our layout. I have split it into two parts. First, in part 1, we set everything up. We use find view by ID to create variables that link to our XML components, the radio group, the button, and the text view. Then we attach a set on checked change listener to our radio group. This code runs the moment a user taps a new option. It finds the selected button and immediately shows a toast, a small pop-up message like you selected bus. This provides great instant feedback. Now in part 2, we handle the final confirmation logic. We attach a set on click listener to our submit button. When the button is clicked, we first check if an option has been selected using if selected not equal to -1. If the user has made a choice, we do two things. First, we update the result text on the screen to permanently display their choice. Second, we show a longer confirmation toast. If no selection was made, the else block runs and we remind the user to pick an option. Now, let's talk about the practical side. In this live implementation demo, we will build the travel mode selector example you see on the phone, which will demonstrate both XML layout design and the Kotlin event handling. Welcome to the practical demonstration. In this part, we will walk through the actual code in Android Studio and then run the app to see it in action. I have the project open here with our two main files, the layout file activity main.xml and our logic file mainActivity.kt. Let's start with the blueprint of our screen, the XML file. At the top, we have a linear layout as our root container. We have set its orientation to vertical, so all the elements inside are stacked one on top of the other. Next are two simple text view elements. They are just serve as a title and subtitle to give our screen some context. Now, here is the core of our layout, the radio group. We have given it the important ID travel mode group. Inside this group, we have our four radio button options. Let's look at one in detail. The bus option has an ID of radio bus and the visible text bus. The train button is special. Notice the line Android checked equal to true. This is the key instruction that tells the app to make train the default selected option. When the screen first loads, the car and bike buttons are set up just like the bus button. Finally, the radio group, we have a button with the ID submit button and a text view with the ID result text. This text view is currently empty, but we will use it to display the user's final choice. Okay, now let's look in the Kotlin code that controls this layout. All our logic is inside the onCreate method, which runs when the app starts. First, we need to get reference to our views. These three lines use find view by ID to connect our Kotlin variables, travel mode groups, submit button, and result text to the components we define in the XML using their IDs. Next, we have our first listener. This block travel mode group dot set onChecked change listener is designed to give the user instant feedback. The code inside this block runs every time a new radio button is selected. It finds the button that was just checked and uses toast dot make text to display a short temporary message at the bottom of the screen like you selected bus. Now for the main logic, the block submit button dot set on click listener defines what happens when the user clicks our confirm selection button. The first thing it does is get the ID of the currently selected radio button using travel mode group dot set checked radio button ID. Then we have this crucial if selected not equal to -1 statement. This is a safety check. It makes sure that an option is actually selected before the code proceeds. If nothing was selected, checked radio button ID would return -1. Inside the if block, we find the selected radio button, get its text, and store it in a variable called selected mode. Then we perform two actions. First, the line result text your choice. Selected mode updates the empty text view in our layout to show the final confirmed choice. Second, we show another toast message. This message take a longer one to confirm the selection has been locked in. The final else block is our fallback. If the user were to click the button without making a selection, this code would run, showing a toast that says, please select travel mode. All right, let's run the app, and here it is on the emulator. Notice that it loads with train already selected. That's because of the Android checked equal to true. We set in the XML. Now watch the button of the bottom of the screen. As I tap a new option, I'll select a car. See that pop-up message? That's the toast from our set on checked change listener. It provides that instant feedback we talked about. Now let's confirm the choice. I'll leave car selected and press the confirm selection button. Watch the text view and the toast. The text at the bottom updates to your choice car, and we get our final confirmation toast. This is our set on click listener in action. Let's do it one more time. I'll select bike and click confirm. The text updates perfectly and the toast appears. So as you can see, our XML layout and Kotlin logic are working together exactly as planned. That concludes our practical demonstration. You see radio buttons in real world use cases all the time. For gender selection in a profile form, in quizzes and surveys to select an answer, when choosing payment methods online, for selecting shipping options during checkout, and in app preferences or setting screens. Let's summarize with some best practices and key takeaways. For the best user experience, you should always group related options using a radio group to ensure they are logically connected. Provide clear labels so that the user knows exactly what they are choosing. Set a default selection by making one button checked by default if a choice is required, and limit the options. For mobile, it's best to keep the list short, ideally 3 to 7 options. So the key takeaways are the radio button is a fundamental UI component for a single choice selection and is an essential tool for forms and settings. The radio group is the exclusive selection manager that controls them. To conclude, let's quickly summarize the core concepts. First, simplicity in choice. Radio buttons simplify decision making by forcing a single clear selection. Second, user-friendly design. The radio group ensures the selection process is intuitive and error-free. And third, industry relevance. These components are foundational and used across almost all professional Android apps. Looking at the future scope, you can take this knowledge further by implementing custom styling and themes using material design, or by dynamically creating radio buttons based on data you get from an API. Thank you so much for watching. If you have any questions, please leave them in the comments below or contact me at my email address. Don't forget to like and subscribe for more content.